So in our previous video, we discussed about variables and we shared some examples of variables. We said that variables are like containers that hold values or data in a way. Um, and we can access them anytime we need to. That's why we create variables. So that in the run of our program, if we have to do any data manipulation, if we have to do anything that requires us to use some information somewhere, then we can store them temporarily as our program runs. And remember that while your program is running, variables are also being used. And when you end the program, your variables also go away. So variables are temporary. They are not saved to the hard disk unless in specific cases you ask them to be saved. Today we are going to talk about operations in R, and it's an interesting dynamic topic. And I'm pretty sure that we'll be fine. So we are still in week 2, and we looked at variables, and we are going to look at operators or operations. So let's get right in with operators or operations. Now, when we see an operation is a process. Operators are the elements that play the role in the process. Okay. So we are going to talk about the types of operations. We have the symbols and their uses. Okay. So first, I'll say R operations. So operators are the symbols directing the compiler to perform various kinds of operations between operands. The operators are the symbols. The operands are the data or the variables. So in this case, you have an operand here, which is like the data or a variable. You have another operand here, and you have the operator in between. The operator tells the compiler what it should do with these two operands. Okay. So I told you earlier, maybe in an earlier video, that compilers kind of they help the machine understand the language we write with. So we write R and write words. The machine doesn't write words because it writes zeros and ones. It writes bits and bytes. So the compiler kind of converts into that form that the machine can understand. Okay. So I just want to demonstrate how an operation, there is a simple, we call this type of operators binary operators, an operator that involves two, let's say, operands. So in this case, we have one variable called v1 being set to 3, and we have another variable called v2 being set to 2 over here. And we say v1 should add to v2. Now, the plus sign or the addition sign over here is the operator. Okay, it's the operator. And these values, v1 and v2, are the operands. Okay. So let's say we have, I just want to demo this. So let's say we have and remember the data in R, data can just be manipulated using an operand. So the operator is in between 45 plus 34 is 79. The operator is the plus sign. The operands are the 45 and the 34. Okay. We can also assign these to variables like we saw earlier. So we have this coming in here as 45. V1 to be set to 45. So you see over here we have V1 set to 45 over here. And we have V2 over here set to 34, which is our second operand over here, 34. Now we can say this operand, V1, should add up to that operand, V2, and it will give us the same results over here. So symbols like these, plus, addition, symbols like the addition sign, the subtraction sign, the multiplication sign, they are all called operators. Okay? They are performing an operation. And in that operation, there are operands. The data or the data that is supplied to it is known as the operands. Okay. Let's get back to so I explained what operators are and what operands are. Operands are the values or the data that is supplied. And it can be in a raw state form like a variable number. It can be any form. Okay. And then the operator runs an operation on them. Okay. And you can also have a unary operator, or unary operator is like a unary operator is like an operator that works on only let's say on a single operand. Okay, I'll demonstrate that. So let's say in this case we say, okay, Nana is set to true. The variable Nana is set to true. Okay. If I say not Nana, that gives me 4 because I brought this exclamation sign. This is an operator which says that negates any operand that follows it. Negate any operand that follows it. So in doing that, you try to negate the operand that follows it. Just using this exclamation sign. It means not. So it's an operator which negates it. And it stands along with a single operand. Okay, so we usually call those operators unary operators. So let's continue with the types of operations. So like I said, while some are binary combining 2 operands, others are unary, combining like the exclamations and the non-thing. So in R, operators may be classified into arithmetic, logical, relational, assignment, miscellaneous. We'll explain what each of them are, or we will introduce each of them. Remember that the important thing in programming is that you won't use all of these operators at the same time. You may use one at a time, or you may even use 2 at a time. Sometimes you write long code without even using operators. However, it's important to understand what they do so that when you see them in any code, you know, okay, well, this is what is really happening in the background. So the first thing is arithmetic operators. Arithmetic are like mathematical operators. So as you can see, we have addition, we have subtraction, we have multiplication, we have division, and these are the symbols that are used. And we have the exponent and we have the modulo, okay? And I'll explain. Addition is simple, add 2 numbers. Subtraction is subtract 1 number for the other. The multiplication, multiply 2 numbers. The division kind of divides them. The exponent is more like the first number raised to the power the second number. So you can have 2 here and you have 3 here. You have 2 raised to the power 3. Okay. The modulo, when we say modulo, it's a mathematical operation where it divides the first number by the second number as many times and then gives you the remainder. So it gives you the remainder. So it's like, let's say, if you divide 3 by 2, some will say it's imperfect, but 2 goes into 3 once, and it has a balance of 1. The balance is what shows up. Okay. And if you have, if you divide 2, let's say 5 by 2, if you divide 5 by 2, 2 goes into 5 2 times, and it has a remainder of 1. So the remainder is what shows up. Okay, so the modulo always brings up your remainder. Okay. And then we have 2 vectors here. The first vector is vector 1, which is C02, The second vector is vector 2, which is 2, 3. Okay. So we'll use them in our demos. Okay. So let's set these two vectors. Let me quit. It looks like we have a mess here, so I want to quit my program and restart it. Yes, but we can have a clean space to demo some of these things. All right. It's key for us to get some of these things demonstrated for us to understand how they work. So all of these arithmetic operators are binary operators because they need two operands, one on the left, one on the right, and it works in between them. So let's go to our RStudio. Now we have this value. This is the first vector, right? That's another vector. So we said set v1 to 0, 2, a vector 0, 2. When you see this, it means we're setting a vector 0, 2, and set v2, which is the second variable, set it to c, let's set it to 2, 3. Okay, so now we have it here. v1, the value is 0, 2. Yeah, this is the x, that's the y. So it's going to do on elementary basis. So if I say add v1 to v2, that's what happens. And you get 2, 5. What is happening here is v1's value is 2, it's 0. So you add it to this, and you have 2 here in the first value. The second one's value is 3. So we add it to this and have 2, 5. Similarly, the subtraction is also similar. So when I say subtract the first one from the second one, okay? So 0 minus 2 is minus 2 or negative 2. And you have 2 minus 3 minus 2 is minus 1. Okay. 2 minus 3 is minus 1. So first one minus second one, v1 minus v2, v1 minus v2. Okay. So that's with arithmetic. So when it comes to these ones are easier to understand. The first one value divided by the second value. So 0 divided by 2, we have 0. That's why 0 shows up. And 2 divided by 3 is like 2 over 3. It's like 2/3. It is 0.67 when you round it up. And the exponent, we have that involved. The exponent, we have first number, exponent, second number. Okay. So 0 exponent 2, any number exponent 2, any number, and there's 0 exponent, any number is 0, right? And 2 exponent 3 is 8. So that's how we have 8 showing up. And with the modulo, that is where the tricky thing is. So the modulo uses double percentage signs for modulo. So v1 modulo v2. So we have this modulo that is like divide any number modulo 0 is like 0. So we have 0 modulo 2, we are getting 0, right? But 2 modulo 3 is like divide 2 by 3, and what's the remainder? So we have 2 here because it goes into it 0 times, and there is a remainder of 2. So that's about arithmetic operators. Okay. The next set of operators we are going to deal with is logical operators. And logical operators has to do with comparing things that are true or false and outputting them if a value of true or false is arrived at. So the output of logical operators is usually what we term as a Boolean value. A Boolean is like either true or it's false. It's not like maybe arithmetic operators where you can manipulate two numbers. Remember, arithmetic operators deals with numbers or numeric variables that can only be operands. You can't have maybe words that are being multiplied. But over here, you can have statement like true and false being compared. So what happens here is any value that is a non-zero integer, that is either a -1, -2 is an integer, +1, +2 is an integer, a non-zero integer is considered to be of the value true. So if you meet, let's say, a vector as defined here, which says the values of the vector are the first value is true, the first element is true, and the second one is 0.1. The 0.1 is considered as true, okay, because it's a non-integer, a non-zero integer. The 0 here is considered as false. Okay, so this is seen as true, true, false, true. This is also a complex value. So it says, be it a complex or a real number, whereas 0 is considered as false. Okay, element-wise logical operators. So we are focusing right now on element-wise. They compare the elements of the vector. So we have a vector 1 here, we have another vector here. It will compare the element, the individual elements. So when we say the operand end here ensures that both scenarios have to be true for the outputs to be true. Okay. In this case, the first element and the second element, the first element of this first vector and the first element of the second vector will be compared. So we have true being compared against 0. 0 is considered as false. For the end to work, for the end to output true, both elements have to be true. Okay, that is, it is true here and it is true there. So if you have one of them being false, then the output false will prevail. Okay, so over here, this element is true, that is false. So the output false will prevail. And that's why when we compare x1 and x2, we have the first element outputting false. Over here, this is considered as true. Okay, 0.1 is considered as true. It's not a zero integer. It's not a 0. 0 is a false. Any other number, negative or positive, is a true. So this is considered as a true. That is also considered as a true. So true and true will output true. When we are dealing with and, it has to be true here and it has to be true here. Both conditions have to exist. When we come to OR, the OR operator is seen using one pipe. That is for the element-wise, when you are comparing elements. So with the OR operator, if one of them is true, the statement will be true. Both doesn't have to be true. Compared to the, as seen in the end, one of them is true, the statement will be true. So the first element here is true. The first element here is false. Even though this one is false, one of them is true. So it will register as a true. Okay. And the second element, both of them are true. So it will also register as a true. That's why we have the first registering as true, because when it comes to OR, when you compare things using OR, then if one of them is true, this or that is true, the output will be true. But when it comes to AND, both of them, this and that has to be true. Okay. So that's about element-wise logical operators. Okay. So still under logical operators, we have operators that are kind of considered as logical operators. And these ones, they use the double signs. So be careful. comparing this end and comparing that end. Okay, these ones allow you to pick up the elements and compare them, not the entire, it doesn't give you the entire output. Okay, so over here you have the end, the logical end. It's not element wise, it's the logical end. So when you see, let's say, vector x1 in a square bracket 1, x2 in a square bracket 1, what happens is over here, this 1 is representing the first element. It's trying to fish out the first element of this vector. And this one too is trying to fish out the first element of the second vector, which is x2. So we are going to compare this first element here of x1, which is identified by number 1. And we are going to compare the first element here of the second vector, which is also identified by 1. That is the position we are talking about, and we will get there with time. So a true and when you see a double operator, it allows you to compare the individual elements. So you can fish out an element and say, I want to compare only 2 and 3. I want to compare this and that. You can fish out independent. When you use the double end operators, you can use that. So in this case, we are fishing out the first element only. So when it comes to end, this one and that has to be true. Okay, in both cases, if both of them are not true, then to output a false, as we said. And for the or, if one of them is true, then it's going to output the false. If one of them is true, it's going to output a true. So we are comparing the first one and we are comparing this one and that one. One of them is true. This is a false, but that is a true. So when we compare them, because this is a true, we will output a true. And not this one negates every, is a unary operator. That is, it comes before the operand. And when it's inserted like this before the operand, the exclamation sign, it negates this one. So if we have x2, what's x2? The value here is 0 and 4 plus. So there's a complex number. That's a real number. 0 is considered as false. That is considered as true. So false here, true here. When we negate it, we'll have true here and false there. And that's why we have true and false as the output. Okay, so now let's discuss relational operators. So really, in relational operators, they help you compare two things and they output true or false. Okay. True is considered to be greater than false. So let's understand that. We have a vector R1 has the elements 2, 0.1, and apple. Okay. And we have this one as 0, 0.1, and bat. True is considered as great, is considered to be greater than false. So here we have a value of true. 0 represents a false, as I said earlier. 0.1 is a true. 0.1 here is a true. And these characters will be compared as well. So when we say in this example, R1 is less than R2, what this vector is going to do is going to compare these two. What this operand is going to do, that's this operator is going to do, is it's going to compare these two vectors such that we have R1 to be greater than R2. And let's first feed that into our software and see how that works with us. So let's say we fed that vector R and vector R2 as this. Now we have to, what do I say? values created here or variables created here. And they are going to compare. When I say R1 is less than R2, it's going to compare the individual values here and tell me whether it's true or false. In this case, I'm comparing R1 to be less than R2. Okay, so the first value of R1, the first values here are true and false. True is considered to be greater than false. So if I say this is less than that, that is false. That's why it gives me false over here. Okay. I compare 0.1 and this 0.1, this 0.1, and that's 0.1. If I say R1, the 0.1 here, if I say the 0.1 here is less than the 0.1 over here, then that is also a lie because they are equal, right? If they are equal, then we have a false here. Now, if I compare this and I say this is less than that, then it's considered a true. Okay. And that's how come we have that output over here. False, false, true. So all of these ones have been said. This is less than or equal to. Okay. Less than or equal to means that it's either less than or equal to. So if one of them is true, it will be true. If one of them is true, it will be true. So because of the or if you have one of for all, if you have one of the conditions being filled or being fulfilled, then your output is going to be true. But when it comes to end, you need both of the conditions to be fulfilled in order for your output to be true. Okay. So that's a very important thing when it comes to comparisons. So let's do this one quickly. Over here, we have true, we have false, we have the first one, true and false. It says this is less than or equal to. Is this less than or equal to false? Is true less than or equal? No, that is not true. True is greater than this, false. So we have a false output here. Let's compare the 0.1, 0.1. Is this less than or equal to? We can say it's less than. However, we have to also compare. So 0.1, 0.1 is equal. One of them fulfills. It fulfills one of the conditions. So we are going to, it's going to run as true. Okay. It's going to run as true. The next one on our table is the greater than sign. Okay. It's going to compare these two as well. And then if this is greater than this, then it's going to output true. So true is considered to be greater than 0, which is considered a false. Okay. So that's why we have the output true here. 0.1 and 0.1, none of them is greater than the other. They're actually equal. But if you have only greater than, then it's going to output a false. Okay. And if you have this to be, when you compare this and you say, okay, is this greater than that apple and bat? It says false. Okay, now let's look at the greater than or equal to sign symbol. This operator will work under two conditions. If it's greater than, it will show up as true. And if it's equal to, it will show up as true. And I told you something about, let's say, with these conditions that when we compare, when we have true, it's considered as true. When you have a number, it's considered as true. But if it's 0, then it's considered as false. So we are going to compare each element over here and then say it's true or false. This time we are saying R1, the statement we are making is R1 is greater than R2, greater than or equal to R2. So it's going to compare every element or each element in here and then flag what it thinks. So over here with the first one, true is true greater than false. This is 0 is false. So is true greater than false? Yes, it is. So it will output true for the first element. The next element is true greater than this, not true. But is it equal to? The or greater than or equal to, it means if one of them fulfills the condition, then true will be passed. Okay, so since 0.1 is equal to 0.1 over here, it's going to pass the condition as true. But over here is apple greater than this? No, it's actually less than. Okay, so it passes false. And the final place is not equal to. I told you about not equal to. Not equal to is like negate this thing negates it. So is R equal to this? When you say not equal to, then it means negates the equal to. Okay. So is R, you compare each of the elements here. Is R not equal to this? Yes, it's true. Because if this was true and that was true, then you say R is equal to. But if this is true and that is false, then it means that it is not equal to. That's why it passed true over here. Is R not equal to this? R1 not equal to R2 over here? Both of these ones are equal to. So it will say it is actually equal to. So that is false. Okay. And over here, it passes as true. So that's about relational operators. And the next set of operators, we call them assignment operators. Assignment operators are the operators that are used to assign values to variables. Okay. So I told you in our previous video that you can use this to assign a video, and a variable or a value to an object. A double. This is for left assignment. When you're assigning things towards the left to a variable on the left. Okay. And this is for right assignment. When you're assigning things to a variable on the right. So you can use an equal to, you can use less than or dash, and you can use two less than or this. Each of them can be used depending on which one is most convenient for you. And when you print out A1, it will still give you the same condition, true and bad, because those values are contained in the vector. With this talks about right assignment, means that the variable is on the right and you are assigning items to it on the right. So this and that are actually equal, but it depends on the nomenclature you prefer. Okay. And this should give you, let's say, the same, you can use that same assignment here as you did over here. C3, which means vector C33 is being assigned to the right variable here. That's why we call them right assignment. And this one, we don't have an equal to. Okay, for right assignment, we don't have an equal to. But for left assignment, we have an equal. You can use an equal to. So these are assignment operators. Okay, assignment operators. And you should take note of them. Anytime you see these assignment, you see these operators, they are for assignment purposes. they assign the left side to the right side of the equation. And finally, we move to miscellaneous operators or mixed operators. They are actually used in special cases. Okay. I told you that right from the beginning, you won't use all of them at the same time, but it's important to be able to identify them when you see them. Okay, being at play or when you need to use a condition like that. So mixed operators stimulate printing of sequences and assignment of vectors. The first one is the percentage in that, in another percentage. So let's say you have a variable called value and it's 0.1. And you have a list, another list, list 1. It contains true, it contains 0.1, and it contains apple. And you want to check if your variable value here or 0.1 is in this list, which is list 2. You want to check if 0.1 is in this list. If it appears in this list, it will flag true over here. So over here, val percentage in percentage list actually means that check if this value, the initial value I placed on my right, is found on the left, is found in the value on my right. And if it checks and it's found there, it will return true. But if it checks and it's absent there, if it checks in here and it's absent, and it will return false. So that's how we use this particular operator. It's used to check if an element is found in a list or in a vector. Okay, so you can have a matrix and then say, okay, check for me if you can find it there. And if you find it, it will return true for you. So if it returns true, then it means that now you can go ahead with your equations. The other one is percentage sign star percentage sign. This operator is used to multiply a matrix with its transpose. And we will talk about matrices soon. Okay, matrices, you find that in mathematics, but it's actually a data type also in R, and it's very useful. So in matrices, you have some number of columns and you have some number of rows. And the number of columns are the same as the number of rows for this rule to work. So here we have a matrix which has elements this. Let's code that and then see what kind of matrix we get. So the matrix is called MAT. The matrix is called MAT, and we are going to input that in our studio and see the kind of matrix we get for MAT. So when we type MAT here, now this is the matrix it created from this code. Okay, so we have a matrix with some rows and columns here. These are considered as the rows of the matrix. 1, 3, 5, 2, 4, 6 are the rows. The columns are the 5, 6, the 3, 4, and the 1, 2. So the first column is 1, 2, contains 1, 2. The next column contains 3, 4. And matrices by default are filled in columns. Okay, so they are filled in columns. So you have this is going to populate it in columns unless you specify that do not fill it in columns. Okay. And out of this matrix created, it says that we should create the transpose of the matrix using a function called tmat. Now, the function called tmat, so let's say we want to create the transpose of its variable feed it, and T is the function for creating the transpose of the matrix. And the value we want to put in is mat, our matrix here. So when we run that, we have transpose to the transpose of the value here. So let's look at what we have as transpose. the transpose of that particular matrix. So now we fed the product into transpose. So we enter, and then we see this matrix that has been transposed. So instead of having the columns have been inverted as rows, and the rows have been inverted as columns. So the row 135 is now a column 135. The row 1, 2, 2, 4, 6 is 2, 4, 6, now a column here. And the columns here, 1, 2 is now a row here. And you have 3, 4 also a row here. You have 5, 6 also. So that is actually what we call the transpose of this matrix. MAT is a matrix. Its transpose is here. Okay. So when you transpose a matrix, that is what you get. You invert the columns into rows and the rows into columns. And after you've done that, then you can say that your final product, this is where it comes in handy. This is where it comes in handy. That's the miscellaneous operator stuff. So for your final product, you want to use this operator between your matrix and its transpose. Okay. So this is where we are going to use it. And when we hit enter, let's see what is in product. Now we have this as a product of this. And what is this called? So the multiplication of matrix A with a transpose B produces a square matrix. So the square matrix is what we are actually after. So a matrix and its transpose, when you use this, you get a square matrix. Initially was, how do I say? It was, you had 3 rows and 2 columns. Yeah. And we had, when we entered it, we had 3 rows and 2 columns. And when we multiply both using this special operator, then we are going to get a square matrix here. So that is how that is used. It depends on the mathematical operation you're actually performing. Some of these things you may not use them. However, it's worth mentioning because you won't know which operation you need to perform at what time. Right, so that's how we use this percentage star percentage operator. And, I think so far we've done some work on the types of operators we have. So first we spoke about arithmetic operators, which we said is for mathematical operations. Then we spoke about the logical ones, which compare element by element and then say when you see a 0, it's equated to false, and when you see a value, an integer which is not 0, then you equate it to 1 or 2. You equate it to 3. Then you compare both. If you use an AND operator, then it means that both conditions have to be true for you to get true. But if you use an OR operator, then it means that if one of the conditions, either this or that, is true, then the condition becomes true. The final output becomes true. And the relational is for comparing two sides to see if that statement is true or not. And the assignment operators are for usually assigning values to variables, which we've spoken about earlier. And the miscellaneous ones are the final ones we tested. So I hope this helps. If you have any questions, I'm available you can comment on your questions, and you can also send me a mail regard to this. Thank you, and I wish you the best in the next lesson. The next lesson will be dealing with data types, which is very important. Data type, very important. I'll see you in the next lesson.